Good afternoon. Welcome to ML Ticket, and we are now in an ongoing project. We are addressing a regression problem. Specifically, we have chosen a dataset from California, chosen a California housing datasets from 1990, and we are trying to predict the median house value. And we have covered a lot of things till date, and we are almost done with our pre-processing. In the last session, we talked about feature scaling, and I said, Jay, that in the last session I never told you how to. Okay, sorry, my microphone was turned off. So let me just start over again. So last session we talked about feature scaling, but only the theoretical aspect. I never showed you the code, and I also told you that the code for feature scaling is very simple. Okay, so the code for feature scaling is not something we should be very bothered about. It is very simple, to be honest, simpler than anything that we have written till now. But today I want to address a situation that most of the programmers, most of the machine learning programmers don't do this. Okay, but it is very good practice to do this because sometimes it helps. So what is the thing? I won't say this is evidently a part of pre-processing, but we can include that into a pre-processing. So let me just present my screen and let's get started. We don't have a lot to cover today. I'm only going to share some of the concepts. To be honest, one concept, very crucial concept, to be honest. So let's see what it is. Okay, the concept is named as pipeline. Now, pipeline is introduced into the scikit-learn so that we can wrap up everything that we have done. If you have noticed one thing, that I have done so many things. I have done visualization. I have done entire pre-processing, data cleaning, adjusting missing values, taking care of categorical values, and numerous other things that I have done. But if you can recall, that I have not applied any of those changes into the original training dataset. Okay, because I always used to say that we will be looking at it in a broader concept. We will be taking care of it later. So this is the day that we are going to take care of it. And today you will understand that what is the best way, that possibly till date, possibly best way to do this thing actually. Okay, so what is pipeline? This pipeline concept is a very important concept for you to understand. Okay, so what is this pipeline concept? There are standard workflows in applied machine learning. Standard because they overcome common problems like data leakage of your in your test harness. Okay, let me just go through all the points, then I'll be explaining everything. Python scikit-learn provides a pipeline utility to help automate machine learning workflow. Pipelines work by allowing for a linear sequence of data transforms to be chained together, accumulating in a modeling process that can be evaluated. The goal is to ensure that all of the steps in the pipeline are constrained to the data available for the evaluation, such as the training dataset or each fold of the cross validation procedure. Okay, so what is the thing? So these are some of the fancy definition of pipeline. So let me just tell you in a very simple way. Imagine that you are carrying water from one place to another. Okay, and you are using a bucket. So when you use a bucket to carry a large amount of water, now you have to make multiple trips. Once you have to make multiple trips, and while going to and fro from the source to destination, you may spill some water on the floor. Okay, that is very common, to be honest, and to be very honest, this is very natural. when you are carrying a bucket which has an open lid, and you are carrying from source to destination multiple times, so it is very natural for you to spill some of the water on the floor. But in a similar way, but okay, let me just complete it. But if you use a pipe, suppose you are using a pipe, you use an extended pipe from source to destination. Yeah, it connects the source to the destination, and you just unscrew the tap, and the water starts flowing. So none of the water gets spilled, right? And the workflow becomes easy for you. Okay, so in a similar way, if we whatever I have done till now, this is the whatever I have done till now is the way, is the same way that we are carrying a bucket of water from one place to another. Okay, so what may happen, as the water gets sometimes spilled, the data, there is a possibility of data leakage or data spilling. So some kind of error may occur, since there are multiple transformation that we are applying, multiple transformation over the data set. Sometimes we want to apply those transformation in a specific linear way, one after the other. We don't want the second one to come first and the first one to come second. Okay, so how do we ensure that thing? To ensure that thing, scikit-learn provides with a library or utility class known as pipeline. It helps us to do the same thing that I've just mentioned. It wraps up everything that we have done, but in a linear sequential of data transforms. Okay, so it will give me the final transformation that I need on our data set. So till date I have not used my I have not used my uh, uh, training data. We have not transformed anything. We have not transformed anything on our training data. I have shown you various methods, various things, but I have not applied those changes. But today we are going to apply those changes. And today we will have our data completely ready to input into our machine learning models. As I said, today is the last day of our pre-processing, and today we will be completing pre-processing. So I'll be also showing you the code, and while I will be showing, I will also show the method that I use for feature scaling. There are multiple methods, but to be honest, I'm going to choose the easy one out, because you don't need to complicate these things. Okay, the things which are easier should not be complicated much. Okay, so let's get started. So let me just import the libraries. So this is the pipeline library. This is, if you remember from the last session, we talked about two types of feature scaling. One is normalization, and another one is standardization. Okay, so I am going to use standardization here. Um, just consider it like that. Sometimes standardization works better, and we are going to use standardization. Later, after we have done with the project, you can try normalization and see what what accuracy score that you are getting, if you are getting a better accuracy score or not. So I'll leave that thing to you. So to apply standardization, it we can do it using standard scaler. To be honest, you don't have to think anything about you just need to understand one thing, that when you have too many data of different scales, you just need to apply standard scaler on the data set, and it will do the job. You don't need to understand how it is going to work, how it is not going to work. You may understand, but it is a little bit complicated, and to be honest, that's too much work into a section that is not very useful. To be honest, you must invest your time into some of the sections which are more complicated, like custom transformations, like many things, like data visualization, different way to use different methods to pick up the missing fill up the missing values and all. These are the things that you should invest your time into, not feature scaling and all. For the beginner level you should not, but after you go into an intermediate level you should care about everything that is going on. Okay, so one thing before I start, if you remember, let me see if I can find that thing. Okay, let me just print it so that you can understand. Okay, let me just run this cell. It is okay. We have a variable known as housing num. Okay, hope that it is available. Yeah, we have a variable using housing num which only contains the float and integer valued columns. It does not contains the ocean proximity column. That's all. That's the difference. And I think we have a housing label. I guess it is called housing label. I don't remember exactly. Let me just check. Okay, we have only created housing num, right? Yeah, we have only created housing num. Whatever. Okay, that's not a problem. So the thing that is that I am trying to say that in housing num variable we have our data without the ocean proximity column. I just need to remind you this thing. Okay, so let me just continue. So how do we use this pipeline thing? It's a fun thing to understand, to be honest. So I am going to use a num pipeline named variable, and I'm going to use the pipeline over here. So how do you use this pipeline? You open the braces, you start a list, and inside that you will create tuples. If you are not familiar with Python, then you may not understand what is tuples, but to be honest, this is a very common thing in Python to use. I would like you to go through that thing so that you have a greater sense of understanding, but it is not something very something which you won't understand very complicated also. It's very simple, to be honest. So remember we had an imputer class. So first we have to think that what are the things that we have to do. First thing that we need to do is to fill out the missing values. So how do we fill out the missing values? We use the imputer class. We have already created that imputer class, so I am going to apply this particular thing inside the what do you say, quotes, is just the name. You just need to give each process a name, so I'm just giving it a name. So the name that I'm choosing is imputer. So what is it, how do we apply imputer? We use simple imputer. If you remember, if you don't remember, just go back to your code. And we are going to use the strategy as I think we used medium. Okay, so what did we do next? We used custom transformation for our attributes, right? So let me just do the custom transformations. Remember, during that period, we never applied this custom transformation on our real data set, but we need to apply, right? So I'm going to use a function. Oh, we have it here, right? Function transformer. Uh, we could have used the custom transformation class that we created, but function transformer is better, so that's why I'm using it. I've already explained that what are the attributes that I'm going to take inside this function transformer. You can just refer back to that video about custom transformation. I think it was the previous video only. And last but not the least is standard scalar. So we have not seen this thing, and I'm going to directly apply this thing. So it is not that hard, to be honest. I just need to create an instance. That's all. Now we are done with our particular pipeline. What do I say? Pipeline variable, right? So we have all our classes ready, but we have not used, we have not applied those changes till now. But now we need to apply those changes. Let me remind you one thing. I have been saying this for a long while. The scikit-learn always returns its values in numpy array format. So it will also return the value in numpy array format. So let me just write the code and first write the code, and then I'll be explaining it in a greater sense. Pipeline also comes with a fit and transform function. With almost everything in scikit-learn comes with a fit and transform function. You have to use this value on housing num. Okay, let me just run this thing once. Oh, we have done it. Okay, no errors, thank god. Okay, so let me just say a few things. Now, first thing that you may argue, okay, why are you not taking the categorical values? We should consider the categorical values. Yes, we should consider the categorical values. But why I'm not taking those categorical values? Because it is wise. Because sometimes when you are doing, these are some of the general rules that you should know, and you should apply these things. When you are doing this pipeline thing, okay, try to separate your float values and your categorical values into two parts. Then we will just combine them. Okay, try to separate these two values. If you just separate these two values, it will make your life easier. It will make you it will be easier to debug if some problem occurs. But if you don't do it, nothing will be changed. If I just do those things here only, maybe nothing will be changed. But it is not a good practice to do. Acha, this is the first thing. Second thing that I need to talk about, that I have that till here I just created all the instances of those functions, but I have never applied them. We apply them when we call fit and transform over this particular data set. Okay, now you will understand. If I just print it, let me print it and okay, as you can see, we have a number array, okay, here. And to be honest, these are the numbers that are not familiar with. These are not the same numbers here. As you can see, these are very different. Let me just, as you can see, that this is the first row and this is also the first row, but they are very different. The numbers are very different from each other, right? So why it is that? Because we have applied standard scalar. I also repeatedly mentioned yesterday. I am also repeating this to today also. Standard scalar or feature scaling is the last step of preprocessing, because once you apply feature scaling, every data gets either scaled down, mostly scaled down or scaled up. Okay, and you cannot recognize the data, because till now you have a sense of recognition. When you look through the data set, you know that okay, longitude latitude is meant to be in float values, but households are not meant to be in float values. But if you can see here, everything is squashed up into some random thing that your brain won't be able to comprehend. Okay, you won't be you feel that the data set you were working when after applying the standard scalar or feature scaling, You will feel that it is a very different, like it's very different. It's very different from what you have seen till now. But to be honest, you have to understand. To be honest, you have to understand one thing. যে apply to the at the very end of your pre-processing. If you don't do it, you will face problems. You will see your data set, because after the feature scaling, many things becomes a little bit odd. Okay, you won't be able to recognize the data set that you have been working for a long while. Okay, so this is one thing, and another thing, and the last thing that I would say, that every as I said, every um, scikit-learn class utility function comes with a fit and transform function. So when we apply this fit and transform function, it starts to apply this particular function in linear way. When first it applies imputer class, then it applies function transformer, then it applies standard scalar, not in some random way. It applies from the first, second, and third, in a linear way. And sometimes this particular ideas, sometimes this particular way, linear fashion is very helpful. As you do more projects, you will understand why it is more helpful, because I cannot make you understand why it is helpful right now. Okay, so you will have to do more projects, so you will understand why it is helpful to have a linear fashion. Okay, so as you can see, we have a numpy array. Now you may always say that, now okay, now convert it into pandas data frame. I want to see the data. I can convert it into pandas data frame, but to be honest, I don't want to, because at the end of the day, we are not going to input the pandas data frame into our model. We are going to input the numpy array. Okay, because it's smaller and it is it is convenient, and it is absorbable by the model very good. Model likes the numpy array. Okay, so I'm not going to convert it into the pandas data frame. Okay, so this is our data. But what about the categorical values? I've not talked about the categorical values, right? So let me just talk about the categorical values. So first thing that we need to do is to select this particular categories. Okay, so let's see what can we do about it. Okay, uh acha. For combining these two data sets, I am going to separately do the categorical values, right? So for combining these two things together, combining these two things together, I am going to use something which is some a concept which is known as feature union. Okay, now feature union is a library in scikit-learn which is present, but to be honest, it's old and now it is replaced by something which is known as column transformer. So I'm going to use the column transformer, but of course, if you want to use feature union, you can. You just need to look up the code online. It does the same thing. It is exactly same thing, but to be honest, I can learn now claims that this is better. So what do we want to? Okay, we have done this. So okay, so now look at it. We created a pipeline, right? Now we need to punch them together. Now to punching them together, I am creating a list of all the columns. Okay, that's why I did this list of housing num. It and also I printed this variable. It lists all the columns. And num pipeline contains this particular data. This num pipeline is this thing. It contains all this pipeline, and I have applied those pipeline on this particular columns, and I applied one hot encoder. We have created this way earlier when we were doing categorical values on cat attributes, which contains actually the ocean proximity only one column, and I punched them together. Now if you look at this housing prepared, it has our entire dataset. We are now officially done. That our officially our dataset is completely ready to be fed into our machine learning models. So I'm not going to extend much about these things, and I'm not going to start machine learning models today in this session. I'll be doing that from tomorrow. So this is relatively a short session than the other session that we have done. But let me go through this one more time from the top so that you can understand. Let me just open the PPT for you. So what do we have here actually? What do we did? What the hell we did for the last half an hour? So the thing that we were concerned were to apply those transformations that we learned all this after all this session into a linear fashion, so that we have an organized way to do these things. Okay, and to be honest, to do these things in an organized manner, we use a utility function which is provided by scikit-learn only, known as pipeline. Okay, which automates the machine learning workflow. That's all. So in the if I draw your attention to the very last point, it is said that pipelines are constrained to the data available for the evaluation, such as training dataset or each fold of the cross-validation procedure. Now you may ask, what is this cross-validation procedure? We have not talked about this particular term. Of course, I have not talked about this particular term because we have a session only dedicated to cross-validation. Okay, this is a very important and interesting part of the machine learning that I'll be talking to. It is a part of checking accuracy scores and all. So we will be talking about cross validation procedure. Just listen to my just believe me right now. This pipeline thing helps a lot when you are cross validating your data set. What is this cross validating your messages? It's just a technique to check accuracy scores and all, and many more things. It also helps in hyperparameter tuning. We will be talking about hyperparameter tuning in some future sessions, so don't you worry. But till date, you need to understand pipeline. Pipeline is the one of the most important thing that you have to do in your machine learning projects. Any project that you do, any project that you do, I would prefer to use pipeline every time. Every time you use something, use pipeline. Make it a habit that you to use pipeline, whether or not you are following a tutorial, whether in that tutorial pipeline is applied or not. You do not care. You just need to apply pipeline. Okay, this is a very good tip, and you should remember this at least for a beginner. As you grow, as you turn when you go into intermediate level, you will learn many other alternatives of this pipeline also. Okay, but the basic concept of the pipeline remains same everywhere. that to automate this machine learning workflow. Now if I see now how it helps me actually. Now we have created so many things, right? Now if I start if I did something wrong in if I applied those changes and something went wrong, okay, these are numbers. At the end of the day, these are numbers, okay. We are not as I also said, we don't our brain cannot comprehend numbers as that fast, like the computer. So if there is a slight problem, we won't be able to notice it, because okay, we won't be able to, our brain won't be able to notice it until the point the accuracy scores are very low. Then we have to go back to our code and start debugging that what went wrong and all. So it is very when you are doing a large project and applying so many transformations, like either we have only applied 4 transformations, okay, but I have taught you many more. I have taught you many more transformations like ordinal encoding and all. I have taught you everything, okay, but I have applied only a few of the transformations, okay. That's why when you are applying so many transformation, 4 transformation is also a good amount of transformation. When you are applying so many transformation, it has a greater chance that you will make some mistakes. You may make some mistakes in somewhere, and some kind of data gets transformed into something that you don't want to, and then you face a problem. Okay, not now, but while checking the accuracy score, you will get a very low accuracy score and you won't be able to know how. You will be scratching your face off, but you won't be able to understand that why it is going on, because you have applied some transformation on something which is not applicable. Okay, and it won't throw you an error because these are something which are known as logical errors. These are not compile time and runtime errors. So nothing in red, you can see nothing in red. So this is not the thing that you will be that you wish to do. Okay, so this is a very good way. Pipeline is a very good process to sum up or wrap up everything that you have till now. Okay, and another thing that I have done, that is column transformer. As I always said during on the very first, that we are dividing our data set into parts. Like first, if you remember, first we divided our data set into the we have separated the median house value, okay, from the data set so that it does not get transformed. Next, we cut off the ocean proximity thing. Okay, then we applied those changes. Then we uh, came back with the ocean proximity thing and punched that to the data set. And from the next video, from the next session, when we will be applying machine learning algorithms, I'll be punching that particular thing also. Okay, particular thing also. So it is a good process to divide your data set into parts and later you punch them together, and it makes your life easier and all. Okay, so this is the thing, and today we complete our pre-processing session, and we are now only left with machine learning algorithms. Under machine learning algorithms, I'll be talking about how to apply what machine learning algorithms to pick, but keep in mind, because if you think that I'm going to do a very extensive lecture, or I'll be talking in a very extensive manner about machine learning algorithms, it won't be, because you are at a beginner level, and if I had to talk in a very extensive manner, then I would have to get down to the math behind that. Okay, I'll be showing some of the things that you need to know, that you need to understand, but not in a not in a very mathematical aspect, because it will be boring for you at some point. Then I'll be talking about some of those uh, evaluation techniques, that how can you check your accuracy score and all, and also the hyperparameter tuning and all, and some more short things, some more little things that you need to know as a beginner. Of course, there are multiple ways to do these things that I am doing this, but since you are a beginner, I am showing the best and easiest possible way for you to learn. Okay, so this is where we stop our pre-processing, and hope that you enjoy your rest of your day. And if you have any questions, please ask. I'll be answering them. And of course, if you later, if you have when you are doing this thing by your own and you come across some kind of questions or weird things that you are not do not understand, just drop a Drop your question on the group, and I'll be answering that as soon as possible. Okay, so now you people can sign off, or if you have any questions, you may ask.